Hello, my name's Joseph. I'm going to show you my custom Kerbal controller. So let's start out really quick. Okay, there's the controller. It's only a prototype, so it's a little bit of work needs to be done still. So first things first, let's unlock the controller and engage the engines. So let's throttle up. And launch. Okay, so we're in the air. Right now I've got this set to show our radar altimeter and our vertical speed. So right now we're reaching 500 meters. A little slow, but it speeds up quite a bit. So we're at a good altitude. I'm going to be using MechJeb here to just make things easier while I try and explain everything that's going on. So now that we're waiting for us to get in the air, it's about time to kill the first set of engines. So let's stage separate. Let's close that for now. Let's also turn on our RCS. Make things a little easier to control. So right now we've got a bunch of toggle switches, a few button switches, momentary switch. We've got a couple of LED readouts, a couple of dial readouts, and a couple of dials. So the dials allow me to select different outputs for these LEDs and for these gauges here. On the dial here, number 1 is apoapsis and periapsis, our altitude and surface velocity, our surface radar altimeter, our vertical speed, and our inclination and eccentricity. These are configurable in the source code, but right now they are preset right now, so I will work on the code more later. We've missed our gravity turn a bit, but it doesn't matter. We've got plenty of delta V in this rocket. And we've also got plenty of dead weight. So let's launch that off. There we go. And start our gravity turn here. Okay. So on our gauges here, we've got our fuel and our oxidizer. On 2, we've got our monopropellant and our electric charge, xenon and air intake, which are not used in this rocket, so they're bugging out a little bit, and our G load and atmospheric density. So G load's one I like to keep it on most of the time for right now. Okay, launch our last bit of dead weight here. Now our apoapsis is coming up to our 100-kilometer orbit that we're looking to form here. Oh, we can throttle up too. Let's throttle up a bit. There we go. So we'll let MechJeb get us in orbit while I explain all the other things that we've got going on. So right now, I've only got a few of these buttons actually working because I ran out of input space on my controller. I've ordered some more GPIO extenders so that I can hook up all the toggles and switches. Right now we've got SAS that'll blink right now because MechJeb automatically turns it off. We've got our RCS controller. These are unused. This is a lock. Our stage controller won't work. Well, it will work. Well, there you go. So I've got a little bit of a bug here. But anyway, we still should be able to get into orbit. Let's let MechJeb figure that out. So, a little bug here. Well, theoretically, it shouldn't be able to stage unless this toggle is flipped up, so I'll have to fix that later. But these first three right now are hooked up to our first three action groups, so I'll flip this and have our solar panels come out. Right now 2 and 3 aren't hooked up to anything but the pretty lights. Now let's see how we're doing on fuel. Well, we still got a good amount of fuel. Still not in orbit yet, but looks like we only need about 1,000 meters per second, so we should be able to get there. Radar altimeter only works up to around 25 kilometers for some reason. Not sure if that's a limitation in Telemachus or Kerbal or what, but I can't get data above there. So this is our eccentricities going down as we burn to circularize. But that's about it for this controller. I'll show you a little bit of the code for how it works. First, I'm using an Arduino to control the actual buttons, knobs, and displays. And it's pretty simple code, so I'm using a few command messengers, a serial interface, wire and LED controls. Wire controls the GPIO extender. I have to hook up all these buttons, and the LED control configures the LED drivers here. Other than that, the code's relatively easy. Wait for a command from the computer, then execute that command. Oh, we might not make it into orbit. Oh well. And then over here, I'm using a Telemachus plugin released under the GPL to talk to Telemachus, and then I'm calling that and writing my own code to talk to this. So it's fairly simple. There's still a lot of optimization and work to be done. Right now it's only updating about every tenth of a second, so it can update quite a bit quicker, I'm sure, once I optimize it a little bit. Anyway, we may not be making orbit here. Oh well. We will just go in hot then. Let's burn retrograde. Let's pop that off and re-enter then. Don't think I really have much more interesting to talk about my controller, but Do some pointless science here. Ooh, 5 science. Awesome. How about a crew report? Nope, no science there. Okay, well, let's switch over to G-load and see what we're going to get while we're coming into the atmosphere here. G-load's starting to creep up. Right now it's going from 0 to 10, so 1 is 2 Gs, 2 is 4, and etc. So we reached 1 G. Suppose I can show you the rat's nest of wires. Just a bunch of wires, an Arduino, some dial stuff, some buttons and LEDs. Nothing special. Almost up to 2 Gs. Three Gs. Let's see. Let's pop our parachutes and see how many Gs we pop up to. There we go, 8 Gs. And then slowly back down. That's physics warp. So the radar altimeter functions most useful so far. Radar altimeter and vertical speed helps landing a lot. Okay. Back to regular warp speed until our parachutes deploy. There we go. Then warp down to around 50 meters. And then go back out of warp. Now we'll just roll down a hill here. Let's try. There we go. Well, thank you for watching. If you have any questions, I probably shared this link with you, so I'm probably in chat with you. But if not, leave a message or a comment, and I should watch this and respond. Thank you.